I know that.
Full screen करोगे ना?
हाँ.
जैसे ये.
I know that. So good afternoon to everyone. It's just last lecture and very exhaustive lecture we have from the morning. Now, no, without saying anything, I'm just starting the lecture. It is not a actually lecture. It's a demonstration. But before going to the demonstration, and which point we are going to demonstrate, and what are we are expecting to see or watching, just look at on that things. First, we are having polymer, otherwise natural fiber. Okay, so polymer is a granule from which we are making the fiber. Okay, otherwise we can have a natural fiber. And finally, we are going to finish folding. Folding means that fabric is processed and then it goes to the garment industry, what already we have seen in the previous lecture. Okay, so from polymer we are getting we will get fiber. So we'll see that fiber spinning. Then from fiber we'll have yarn by certain machineries. Then we'll have looms. Looms, there are different types of looms are there. We'll see those looms, and from fiber we can get the fabric direct itself. That is done by non-woven technology. That also we'll see here. Then from fiber fabric to the finishing, we'll have different type of dyeing machines and finishing machines. So we'll see that. Then in between we can have the printing process, printing machines. Then we'll have the effluent things, because whenever we are processing the fabric we use mainly lot of water, and this water is going to the environment. So before releasing this water to the environment, some portion we are reprocessing it, we are recovering those effluent, and sometimes we are just releasing to the environment. So before releasing to the environment, we have to check whether the this effluent is safe to the environment or not. For that we have to go for some testing that is done by AAS and GCMS, that will be discussed in details. And then when we are getting the fabric, we'll go for some kind of testing whether the quality is meeting the fabric or not. For that we have different types of testing, and we have also chemical testing. Chemical testing means these are whenever we are processing the fabric, some chemicals we are using. So those chemicals are actually meeting the performance, so that also we'll check. Okay, first one is that we are going to have the fiber spinning process. So melt spinning, where the polymer granules are actually make into the fiber. Here this is the place where the we are putting the polymer chips, that is called hopper feeder. Okay, so we are just running the machine. See that. So this is the hopper feeder. Then it goes to the extruder. This is the extruder. This place is the extruder where the heaters are there. Now this is the control panel from where we are setting the temperature of melting and spinning. Here different zones of heating zones are there in the extruder. So we are controlling the and the speed of the spinning speed, because if you can remember that we said about LOY, HOY, FDY. So that speed is set from that control panel, and this is the place where the fiber is coming. Here this is the top of where the spinneret is given placed. So from the spinneret the fibers are coming out, and this place is the spinneret. Here, then this is the cooling zone, and after cooling that fiber becomes solid. Then it goes to the godhet or roller, we can say drawing zone. So that will come. These are the godhet, first godhet. So from where the fibers are wounded, and then it goes to the another one. So where we can give some kind of draft kind of thing, so that that fiber is extended, okay, or drawn, and it is the winder at the bottom. There is the this place is the winder. Here the bobbins are kept and it is wind. So this is in short the spin process. Then that from the yarn the fabric is made. Okay, so before getting the fabric, if you can remember that we have sometimes some design fabric. So that design is done by some kind of dobby design. So those dobby design are done by the card punching. Here we are giving the information to the machine by punching. Means see here the patterns are there. So where the holes are there, there is some pattern. So according to the pattern, the hooks are coming out or going out. So this pattern will determine the design in the fabric. Now see how it works. So here from the design they are putting the giving the information. Maybe some kind of internet issue. फिर से चलाएंगे. Okay. I think there is some problem. We are running it once again. See, there are the hooks are there. Different hooks are there. So from the design paper, we are just punching those switch, and it is actually punching on the cards. Okay. So it's the next step. So we are getting the design like this. Next, from there, this is the machine where we can feed the design, and it can goes to the normal power loom. So where this is the power loom where the fabric is made from the yarn. In the back there is a beam. So the yarns that is called work thread, it is wound on that beam, and then it comes to this cloth end. Okay, now there are transverse yarn. which is wind on a shuttle. Actually, the parn is there. In that, the parn is fitted on the shuttle, and shuttle is moving from one direction to another direction, and again from that direction to the first direction it is coming. So let's see how it works. So I am switching off my video, whether so that it may work better. Let's check. No, better. So also here it is the beam from where the yarns are going. There may be some internet problem. Yes, but normal chala ke dekho. Just see.
Sir, instead of PPT, if you are running from the desktop, I think that may be better.
Yes, sir.
Instead of PPT, if you are running it from the desktop itself.
Yes, sir.
That will be better.
Okay. Let's try.
Let's
try on that.
Yeah.
That is power loom. So how the power loom works? Sir, what I am trying is I am just logging out and then again coming back. So check if is there any some system issue or not. Because before the presentation, I just run those things and it was working nice. Okay. Just giving 2 minutes.
Yeah.
इसमें कुछ
all the participants are requested to be connected. Speaker is checking his presentation and coming back within a minute.
Sir, make me presenter.
Yeah. Yes, sir.
It does not make any difference.
What is that? Let's check.
Sir, just check once again the network, whatever is remained.
Network is there. Let's check.
Yeah. Okay.
Now.
Yeah, it is seen properly. It is better than last times.
What happens when I am connected with this webinar? Then there is a problem. Otherwise, the system is running properly.
Yeah, yeah, network thoda sa issue hoga, sir.
Network issue. So how to find out, because that video is not running, because there are a lot of videos that there. So we should start on the some other computer. Just we are just checking. Okay, who is connected with the LAN?
Then till that we can have some other.
Otherwise, I can continue. Sir. I think whatever coming, it's okay, and we are continuing just.
Yeah, that will be better.
Sir,
Okay.
hello.
Sir.
Sir.
Yes, sir.
Actually, even if there is some network problem, the video will not be working like that. Maybe with one or two video, the issue may be there at that particular your
okay. Let's see. Let's see.
We can continue, because I don't think that network issue is creating problem.
Okay.
Maybe with any one video you can run now from here. Okay. You can run from here any one video directly.
No. No. I think it will work for some other video. Okay, let's continue from here.
Or sir, you can do one thing. Hello.
So this is how the power loom works. The shuttle going from one side to another side. This is the shuttle. Then the back side there are yarn beam.
Sir, hello.
Okay. So yes, sir.
Instead of that VLC media player.
Yes, sir.
Is it possible to play it with Windows media player?
Okay, sir. Okay, sir.
You right click on that and you say that play with. Windows. Let us try with this.
Okay. I think it is working fine. Yes. So these are the called wheel frames, and this is called reed. Okay.
It is working,
the
sir.
Back side there are
it is
yarns.
working
These are the yarns. These are called what yarn? Then
now it is working effectively.
Weaving.
Now it is working.
These are called wheel shaft, which is making the path for the web. Okay, so this is the front side. This is the shuttle where the weft yarn means transverse yarn are wounded, and just then it started. So the shuttle are moving from one side to another side. Okay. So this is how the power loom works. Mainly this type of power loom, which is old version of power loom, which runs only in single motor. The speed is very less. It is works around 120 to 150 RPM, means 120 to 150 picking is done for the webbed insertion rate, that is called webbed insertion rate. Okay, so the warp yarn and webbed yarn making the cloth. Now all the advances come in this webbed insertion rate and web insertion technique. Here the shuttle means it's a huge amount of mass is carrying. Okay. Next is air jet loom. Now in air jet loom, first one. The speed is very high. It goes up to 700 to 800 or even more than that RPM. So here there is no shuttle. Instead of shuttle, just air pressure will carry the webbed yarn from one side to another side. Okay, so here is the warp beam. Warp beams are there at the back side. Then these are the field shaft. Field shaft is moving very fast. It is 700 to 800 or even more than that RPM. Okay. So the webbed is also much more. You need not to stop in between. This much amount of webbed yarn goes through this, and there are air nozzles are there. This goes to, these are called webbed accumulator, and this is giving the control wave. So this is the nozzles from where the webbed yarn is going from one side to another side. Okay. This is moving very fast. From this side, the webbed yarn is actually picking, and the other side, it is just gripping the other side. So here these are the reed, and in between there are some kind of sub nozzles which is actually help in carrying out the webbed yarn from one side to another side. So it goes to the other side, this side. Okay, so that's this is power efficient, we can say, because this side the webbed yarn is coming and it is gripped by the gripper. Okay, because we need not to carry the whole shuttle from one side to another side. Here only the yarn is coming, so that mass of the yarn is very less. And again, if this air is replaced by water, so that we can carry the webbed yarn more efficiently. So that is called water jet loom. Instead of air, we are using water. Last. But sir, I think it is now audible and running.
Yeah, very good,
properly.
sir.
Okay, sir.
It is excellent now.
So this is water jet loom, where the water is used to carry the webbed yarn. Here from here, see the nozzles are there. This is water actually. Water is carrying the webbed yarn. rest of the things are almost similar to air jet loom. It is also running very fast, maybe more than 500, 600, even more than that, depends upon the quality. And yes, this is particularly for synthetic, which is synthetic yarn, which is mainly hydrophobic in nature. The weight is very light. It is not mainly used for cotton. And the previous one, which is air jet, that is used for slightly heavier yarn, say coarser count, or mainly used for cotton, mainly for making denim fabric. So the heel shaft system, the other systems are all almost similar. Okay, so it is also the web yarn is coming to the other side. There are grips, and this way the fabric is made. So the fabric is wet now. One thing we have to be sure that the quality of the water should not affect the nozzles and all the machine system. And when it goes out, so recovering of the water, or say if it is going to the effluent, then we have to treat the effluent, or so many things we have to keep in mind. Okay, and for the water, we need to install the RO system, that is reverse osmosis system, to clean the water before coming to the machine. Okay, now we have seen that from yarn how we are making the fabric by different machine, like power loom, air jet loom, water jet loom, like that. Now there is another technology which is called non-woven technology, from the fiber itself we are getting the fabric, and those fabric mainly used for different technical textile use, like say making of medical use, some kind of things, mainly it water filtration, wipes, so many mainly filtrations and wipes, carpet also sometimes. So we want to, we'll see that how it works. So first one, what we are saying, it is called needle punch. In needle punch technique, just the wave is made, wave of the fibers are spread from carding machine. So these waves are coming, and we are having some needles, so which we actually bind those fiber layers, which will make you give you a fabric. So there are so many needles are there, and what we can control the needle depth and the needle density, all these things we can control, and obviously the RPM of the machine, so that how much punching is done within a minute. So by these three we can control the quality of the fabric. So this way the cutting system and all these things will show in the next video, that is single. Here we can control the system. So needles are going ups and downs. In this way we are getting the needle punch fabric. So here are the needles are there, so its needles are going up and down. Next, followed by water jet, that is water jet or hydro entanglement or spunless, whatever we want, we can say that. So from here the fiber is fed to the cutting machine. So this is called slightly opener. So when the fibers are coming from the belts, it goes to the opener, then it by the air suction it goes to the another unit, from where it goes to the carding unit. So this is the carding unit. See that these fibers are going to the carding unit. It is individualization of the fibers and it is making the fiber web. So you can see the fiber web is forming here. This is the carding machine. So see this is the web. Okay, so this web is going to the cross lapper. Cross lapper means where this web is basically layered in cross direction. See, this is coming to the cross direction from this cross lapper. Okay, so the fiber web is layering. Okay, now it goes to the. So another thing what I want to mention, so this is the way how we are getting the needle punch also. Just before coming to this unit, if we reverse the direction, there is another unit that is called needle punch. The fibers going to that unit also. Okay, now coming to this spunless or hydro entanglement. Here there are three jets. One is pre-wetting jet. It is the pressure is very less, around 40 bars. Then this fiber layer are wet, and there are another second jet where the water jets, very teeny jets are there at very high pressure, around 150 bars, and there is third jet. So now this wave is converted into a fabric. So this is called spunless non-woven fabric, and it goes to the drying unit. So it goes to the drying unit. This is the entry level of the dryer. Okay, so this is the control panel of the hydro entanglement machine. Now it goes to the dryer. So dryer, we can set the temperature. After drying, it's coming out and it is wounded in a roll form. So this is called hydro entanglement fabric. This type of fabric mainly used for wipes and medical use purpose, and needle punch fabric are used mainly for filtration purpose, air filtration kind of things. Okay, needle punch already we have seen, spunless hydro entanglement we have seen. Then going to the processing and dyeing and printing. So I am it is over to Mr. Parikh. He will explain rest of the presentation.
Now, before we go to this dyeing and printing, we have shown you the some of the processes at the laboratory stage, and again we will go to the our Pandesara, this extension center, where certain jet dyeing and stentor is installed. So some of the process I will show you how it is done in laboratory, and then one or two machines I'll again take you back to our center where commercial scale jet dyeing and stentor is installed. Then we will also go through some of the testing methods. So this is the remaining part. Now this is this particular machine is a laboratory dyeing, particularly for polyester fabric. Polyester, as you know, it is dyed in a closed vessel under pressure at a temperature of 130, and pressure is always there because it's a very high temperature, high pressure dyeing. Generally, the beaker, this is called beaker dyeing machine because there are small beakers having which are closed very tightly, and in those beaker you can add the dye bath and a small swatch of the fabric for dyeing. And these type of machines are always installed in laboratory of all process houses, or even if it is a composite mill, then these machines are installed in laboratory. Generally, these machines are glycerin bath beaker dyeing machine, but this particular model I am showing is working with IR and not glycerin. So it is less polluting, and it is more, I mean, quality wise, it is very good because of the infrared. It can hit the all points. There is a uniform heating, and you get a very uniform time. So here this gentleman is explaining the machine. Is just opening the main door of the machine. These are the beakers. This is the solution that is a dye bath he has prepared with the dispersed dye, water, and some acetic acid for maintaining pH. And now he is entering this dye bath. It is called dye bath. It is a solution of the dye with chemicals. And now he is entering the fabric with glass rod. And then he will is placing the lead, which is tightly, I mean, sealed, and then it is placed in the holder. Is showing that is placing it. It is very. This is a Korean machine, actually made in Korea. Indigenous machine are also now made by one company at Vapi. So now this is a programmer. He will program it. He will start it at, say, about 35 degree and then raise to 70 or 80, and then again he will rapidly raise it to 130. There will be some hold time and then some cooling time. So after programming is starting the system. Now he is running the machine. Now he has started the machine. He has actually placed only one beaker. Otherwise, it can. The machine has capacity of about 12 beakers at a time. And this you can see the light, infrared light is there. That is for heating purpose. So heating, switching on and off will go on according to the dyeing rate and rate of rise of temperature. So that will be continued, and dyeing all cycle will require, say, about 1.5 hours or something like that. It depends on your individual choice. And then at the end of the program, he will open the door and take out the beaker. Generally, as I said, generally it is a big glycerin bath beaker dyeing machine, but this is a latest version using the infrared rays. Now he is opening the beaker. You have to be very careful. It is very hot. Although some cooling time has been given. It is actually air cooling, by which it is cooled. There is no water for cooling actually. It is waterless, I mean, machine. So this is the dyed sample. Now he has added that blue dye. It has completely, I mean, and you can see the rest of the spent water is almost colorless. So when you dye polyester 130, you get a complete, fixation of the dye. Now, what is next? Padding mangle. Now, padding mangle is used at many places. It is also used for continuous dyeing, where dye solution is impregnated. But here we are showing you the finishing of a dyed sample. So this is a dyed, I suppose it's a polyester fabric, and he is immersing it or dipping it in a finishing agent. It may be a softener, I suppose. And what he will do, he will pass this dipped sample through the nip of the roller, and under pressure, it is about 4 pounds per inch square, I think. That pressure is applied, and 4 to 6, 6, I think, is 6 pounds per inch square, and he will squeeze the excess amount of finishing agent, so that the finishing agent is impregnated uniformly on the fabric surface. So this is a generally it is done in a continuous fashion, but this is a laboratory padding mangle, so it is done in a manual fashion. So gentleman on the rear side is taking up that fabric. So this is how it is padded, and in industry it is a continuous machine where fabric is dyed fabric is passed through this padding mangle in a continuous fashion, and then it actually continuously goes to air dryer, dryer, float dryer at 110 to 120 degrees centigrade. Here we have dried it in air. Now we are also having a for fixation there is a chamber, and he is just placing that padded and squeezed sample in a frame. Now this frame will go inside the machine for fixation of the polymeric material, which is softener. So when that sample comes out of the chamber, it will be a finished fabric. It will have a very good softness. Generally, this is being done in a stanter, which I think Professor Bade will describe the machine tomorrow in his session. This is a laboratory, you can say, a mini stanter type device. So it has already been programmed digitally on the sideway panel. What should be the temperature and what should be the time of the heating. So that has been programmed. Now, as soon as it reaches the fixation temperature, the fabric sample will be taken inside for fixation, and then the fabric will be fixed and the finishing will be imparted. In case if you want to go for a dyeing, instead of padding with finishing solution, you can padding is done with the dye solution, and then again it is fixed in this steamer or a curing chamber. So the sample has been taken inside the chamber, heating chamber, and then it will come out after some 2-3 minutes or whatever time that has been set in the programmer. Okay. Now we have already seen the laboratory dyeing with the IR beaker dyeing machine. The same thing. We have got a commercial scale jet dyeing machine at our Pandesara Extension Center of Mantra. I will show you how jet dyeing is actually in industry people are working. So this is the main vessel of the jet dye. This is the heat exchanger. This is the head dye tank. And this is the nozzle where fabric is taken out from the machine, main vessel into the jet. And jet is the device where this is the, I think he's taking out the fabric which has been scoured or something, pre-treatment has been done. So that fabric is going out after the treatment. So jet is a device where some Venturi effect is applied. When pump forces the water inside the jet, there is sudden tapering of the diameter of the pipe, and it creates Venturi effect. And there is a high pressure under which the fabric moves along with the dye solution. So that is the jet dyeing principle. It is a working at a very high RPM, and fabric and the solution both are moving in the same direction but with differential speed, which gives you a very good quality level dyeing and with minimum amount of water and energy. Now next is a drum. A drum is nothing but, as I said in yesterday, I talked about it. It's a relaxation shrinkage. When we went for the video, it was not in the working condition. So I will show you how it is. It is just like a high pressure horizontal drum, and it has got a perforated basket in which fabric is loaded, and water is filled in the machine. It is closed. This is the lead is closed, and then it is I mean, temperature is raised to say 130. It is only a plain water, and it is under the heat and pressure, the yarn of the fabric get shrinkage, and the fabric is shrunk. This is actually for having some finishing effect on the fabric, and this particular device is consuming a lot of water. But because we are using the plain water, as I suggested yesterday, you can go for reuse of the hot water, which is for the next batch. This is also a hydro extractor. Generally, after dyeing or scouring, whenever you want to dry the fabric, it is actually when it is taken out from the high pressure machine like drum or jet. Then before entering to the stentor, the excess of water is squeezed out by placing the wet fabric inside this hydro extractor. It is loaded with some wet fabric, and then the lid is closed, and then the entire cage is rotated centrifugally, and with the centrifugal force the water is taken out from the drain pipe, which is situated at the bottom. So it is a must. I mean, this type of machines are required just before entering the fabric for further drying in stentor. Now I will show you the printing. It is a actually laboratory process that I will be showing you. How in laboratory we carry out, although in the industry it is being done in a continuous machine like flatbed machine or rotary screen printing machine. Now the gentleman here is weighing the dye powder according to the depth or color of the fabric, a design you want, and then he will prepare a thick paste of gum paste for making a colored paste out of this dye. So these dye is taken on volume by volume basis. Then he will also add some water, some wetting agent, and try to dissolve the dye in smallest quantity of water required. He is adding some chemical which is required for the fixation of the dye. And So addition of chemical or printing auxiliary is being done. It's trying to dissolve it in very small amount of water. And after that, he has prepared a very thick gum paste. It is tamarind kernel powder, TKP gum. So that is available as a powder. It has to be stirred in water, hot water, and kept for some time to get perfect viscosity. Now he has added the paste, and now he is preparing a thick paste. And in laboratory we have got a small screen. Screen is in laboratory it's a wooden frames screen where bolting cloth has been fixed, and a design is created by some lacquer is applied. It is some photochemical reaction is taking place, and we develop design on that. So preparation of screen is also there. Now he has applied the thick paste with the rubber squeegee. Now he is lifting the screen. So you have got this single color design on white fabric. Now before we steam it, actually steaming is done for fixation. Before steaming, we have to dry it. So in laboratory, we dry it by air hanging the sample in air. Now the same loop steamer is there. Loop steamer is working with high temperature steam, supersaturated and superheated steam. Generally 170 to 180 degree centigrade is required, and some 5 to 7 minutes are given for fixation. So during that exposure, the dye from the surface, which is placed on the surface, goes inside the fiber, and you get a color fixation, a colored print. Now we come to stentor. Now Professor Bade will be talking about this stentor machine. Stentor is a machine which is used for many purposes, for drying of the fabric, as well as for drying of the fabric, as well as for heat setting, particularly for filament, synthetic filament fabrics. Heat setting is a very important step which gives dimension stability to the width and length. It fixes the width and length of the fabric. This is absolutely a very important step, and stentor is very important where any processing is being done on any fabric. But particularly for polyester and nylon fabrics, heat setting is a very important process which decides the stability of the fabric. Now here, fabric passes in open width, and it is loaded in open width form in the trolley, and then it goes to a padding mangle. This is the padding mangle, 3-ball padding mangle. It is actually padded with water, so they don't enter straight away. Many times finishing is also done on stentor, so fabric has to pass through that finishing paste. But here I think it is heat setting, and heat setting is done by passing the fabric through water, which may be on acidic side, and then it is squeezed by passing through the nips of this padding mangle, and then it enters the main chambers, heating chambers of the stentor. Before that, it passes through the straightening device and tension device. Here the operator is standing, the fabric is fed from the bottom of the stand, and then as soon as he enters this thing, there is a conveyor chain is there where selvages are fixed, and this is the control panel where if you are heat setting a polyester, generally it is set at 200 to 210. For nylon, heat setting temperature is 180, and if you are drying, finishing it, it's generally 160 or something like that. So when the fabric enters the series of chambers, it meets hot air. Now hot air is made heated by some heat exchangers. It is based on thermic fluid. Dr. Bade will be explaining this machine in detail, but you can see how it enters the machine, and there are 2-3 chambers. Maybe for cotton it may be more than even 7 to 10 chambers. So at the other side, rear side, you get heat set or dried fabric. So this is a important drying and heat setting machine on which Professor Bade will be. In fact, Mantra and SVNIT Department of Mechanical Engineering, we are working on a joint project, and he will also explain what we are doing there. So next. Now, after your dyeing and printing are over, which actually, and before that there is a pre-treatment, scouring, bleaching, everything is there. So from all water from all these processes, it is taken into a equalization tank, what they call a equalization tank, where all the batch-wise process water and water from printing washing machines and all this, it is received in a tank which is called equalization tank, and then it goes for effluent treatment, what they call. There is a primary treatment where settling is done, and there is secondary where biological treatment is done, and then it may be a tertiary treatment where it may go through a carbon bed, or it may go for ozonation or chlorination. There are some tertiary treatment. So after that, your treated water is ready to be drained off in some receiving water. It may be river or riverlet, or it can be released to an open area. So in Mantra lab, testing lab, we have to test these effluents for the parameters. Yesterday I talked about COD and BOD. So these are the main testing, and further heavy metals are also not allowed in effluent. So now I will explain you the AAS, atomic absorption spectrophotometer. Now this is a device which measures concentration of heavy metal ions, like say lead or mercury or maybe chromium, zinc or something like that. So this is the very accurate and precise machine. It can measure the because heavy metals are allowed in ppb level. So this machine can test the concentration of heavy metals up to ppb level. So it has got very high accuracy. Actually, there are specific lamp available, and you can see that there is a flame. So according to that lamp, you will get, if you have placed a lamp for say silver, so that flame will actually measure that thing is concentration of that heavy metal silver is measured by the presence of silver ion in that flame. So it's a very accurate machine. Now we have got GCMS, gas chromatograph with mass spectrometer. Now this is a machine which measures the ecological parameters. Actually, certain dyes, when you wear a cloth, and if your cloth is having some dye on the printed or dyed area, and if that dye subsequently release amine, which may be carcinogenic or allergic. So it came, there was a famous ban called German ban. So Germany in 1999 or something like that, around that, they came up with this list of 20 amines which were carcinogenic, either carcinogenic or allergic. So they say that if your fabric is having colored with those dyes, releasing these amines, then it is not ecologically, or it's not good for the wearer, and they banned that. So this particular machine, we are using it to identify whether your dyed or printed material is having a dye which subsequently release some banned amines or not. So it is a pass-fail type of test. And what we do, we take a very small sample, we dissolve it in some solvent, try to degrade the dye into fragments, into amines, and then we inject it into this GCMS. And there is a, the peaks are detected by detector, and there is a software which tells whether any of those banned amines are there or not. So it's a very sophisticated machine that we are having, and it has been used by exporters, particularly those who are exporting it to European countries, because they are very strict and they are having very strict norms for eco parameters. Next. So now we come to our chemical and mechanical lab, where we receive samples from industry for their purity, or we also receive chemicals from process houses, and there we receive some dyeing chemicals, printing chemicals, and also fuels. So we receive on a routine basis, we receive samples of coal or lignite, and here we measure GCV of that fuel. For that we are using this bomb calorimeter. So in bomb calorimeter, actually we are taking this very well ground sample of coal or lignite. It can also be a sample of sludge in case if it is received from effluent treatment plant. Then we can also test GCV of that sludge. So now coal sample is being taken in a small crucible, and after accurately weighing, it is about 1 to 2 grams that we take, and we accurately measure it. And then this crucible is placed in a holder of a bomb. Now this bomb is of stainless steel, it is made, and it is there is some cotton thread is dipped inside that. It is wound on that electrode, where afterwards the spark will be generated, and there is an oxygen cylinder. So now she has prepared that crucible, and cotton thread is inserted, which is connected to that electrode, and now she has taken some distilled water. So distilled water remains at the bottom, and now she will tightly, close it. It is perfectly tightly, sealed, and now he is fitting that oxygen pipe, which is oxygen is coming from that cylinder. Now she is starting the oxygen flow. And now when spark is given from outside, the spark will, due to oxygen medium, oxygen is there at high pressure. So a small spark will burn the lignite or coal completely in a fraction. And then she immediately takes out that bomb, and now she will place it into that water bath. The initial temperature of water is measured, and then after, I think she is now applying that spark. So after placing it into the water, the temperature, initial temperature is measured, and then she will now give that thermometer is inserted into that vessel. This is how thermometer is inserted. Now she has started that spark. The current has been passed, and now the temperature, because of the burning of the coal, the water temperature will rise, and that is measured. So at the end, there is a formula from where you can get, for burning of certain mass of the coal, what is the temperature rise of that water, and from that formula we can calculate GCV. Now viscometer is also one of the important part, because we have to measure viscosity of, for example, thermic fluid is measured on a routine basis. Then viscosity of printing paste is also very important. So this is the redwood viscometer that we are using. It is a viscometer where there is, at bottom there is a very micro aperture is there of desired the orifice is there, and a thermometer is inserted just to observe the temperature of that material, because thermic fluid maybe sometimes viscosity is measured at 50 degree or something like that. So a thermometer is always required, and it is a very simple device. Initially you have to place a copper ball which is there, brass ball is there, which closes the orifice. Then you place some 50 ml measuring glass, lift the ball, allow the liquid to fall, and you measure the seconds, time of passage, time for collection of 50 ml of that liquid, whatever, thermic fluid or a printing solution, and the viscosity is measured in terms of redwood seconds. So it's a standard apparatus, and we are also having Brookfield viscometer where stress and strain curve is also obtained, and which is for Brookfield viscometer is used for very thick paste or something like that, material very thick. Now coming to the next, we are having laboratory microscope, and then we will have
So the microscope is just adjusting the focusing, try to focus. So there are two lens, object lens, and it's running very fast. Okay, it's so he just try to adjust, and you see in the software there is possible to image builder software. This is image builder software, so that we can focus on different depth. So first layer we focus, then we just go to the next layer. We can build a image where the various depth is also possible focusing, and by the analysis of the software we can measure the diameter and the pores, all these things we can measure. And above all, we can see the longitudinal view and the cross-sectional view of the fibers. So by the cross-sectional view and longitudinal view, we can identify which fiber it is. Sometimes it is not possible to identify between the, say, nylon or polyester, as they are looking both similar. But if we have wool or say cotton, we will find out the particular signature of the fiber. So that texture of the woolen fiber is not similar to the cotton fiber, or say jute fiber is slightly different. So that by this image and our master image, which is available for different fiber, we can compare and we can identify the fiber. Okay. Next is tensile tester. Okay, let's see. It's a universal tensile tester, and it works on constant rate of extension principle. Okay. Oh, sorry. So it's just running. So the upper jaw is movable, the bottom one is fixed. So just it is moving upward, and we can see that stress strain curve or say load elongation curve. We can have it. So it is just recorded over here. And so the capacity of this machine is 50 Newton. 50 Newton. We are having different types of load cell can be fixed over here, the upper part. And it is coming back when the break is detected. Normally, break is detected after say 20% fall of the strength. So it is reversing back to its original position. So from here, so we can just change the axis. It is time, but we can change the axis up to say elongation or say strain, whatever we want. Next is laundrometer. This is important to find out the fastness property. Fastness property means just see he's cutting a fabric. Okay, so the color of this fabric has to be assessed. Whenever we are going for washing, so after washing some of the fabric become faded. So that means the color is changed due to washing. And sometimes if we wash 2-3 cloths together, suppose there is one white cloth also there, so sometimes that white cloth is stained from the other cloth, so that test also be done over here. So this white cloth is actually working as an adjacent fabric. We take this and we'll stitch that. Okay. After cutting this, so this fabric is stitched together. Then we put this fabric inside a vessel where we give the solution. Solution means soap solution or say soap soda solution. So that depend upon the intensity of the washing. Okay, sometimes we run it on 40 degrees centigrade, sometimes in 60 degrees centigrade. Sometimes we put some steel ball over here. So that actually determine the intensity of the washing. Okay. So this is the soap solution. Now their sample is also kept over there, and we close it. And we set the temperature, which temperature? So 40 degree they are setting, 40 degree centigrade. No, maybe 40 or 60, whatever. That depends. Oh, 40 degree. They have set 40 degree. Okay. So now they place this, and it will rotate for a certain time. Sometimes it is rotate for say 40 minutes, sometimes 30 minutes, sometimes 1 hour, like that. Now it will run. After that, they will take it out. So just it's moving on that way. So after getting back, you just take it out. Now it will washing, and then it will dry. Okay. See, this fabric is having this is called multi-fiber strip. There are wool, nylon, polyester. So different kind of fiber is there, because we don't know what kind of fiber we are using for our garments whenever we are washing our clothes. So there are different 7 types of fabric is there, so that in any type of fiber, whether it is stained or not, we can assess. Then after that, we will check that whether some staining has been done, or the color fading is done, so we can compare. Then this is geno test. Here we place the fabric over here, we cut the fabric, and here we are having the artificial light. Okay, so it rotates for some times, and after that we will compare with the original fabric, how much the color has been fade. Sometimes the standard woolen sample is there, so we can compare with that also. Now after checking whether this fabric is passed the quality or not, so after if the quality is passed, we can fold it for further use, or to send the market or send the garment house. See, the folding is done over here. This is the colored fabric. Okay. So that's all about the virtual lab. And for this, Mr. Rahul has helped a lot to prepare video. So thank you, sir. Thank you for watching. Now